Okay. Hello, everyone. My topic for my presentation is relative age dating. Oh, sorry. Okay. To talk about relative age dating, we have to talk about its um, compared form of dating the earth, which is absolute dating. Which, with absolute dating, it's more about numbers and getting the actual date for the actual fossil or rock that we're looking at. Mainly igneous crystals or rocks and organic tissue. But relative age dating, it places um, not a number on the thing that we're dating, but it places just a relative time. It uses the words like older and younger instead of exact numbers to determine how old something is compared to something else. So then we have to talk about relative age dating principles, which are superposition law, law of original horizontality, cross-cutting law, and law of inclusion, or intrusion, two different things, but law of inclusion for this one. First, we're going to talk about law of superposition, which is the most basic form of one of each of the laws. Law of superposition is when sedimentary rock layers are deposited and younger layers are on the top and older layers on the bottom. So the most simplest definition of it. And then the example. And then next is the law of original horizontality, where the sedimentary rocks are deposited horizontally. If they are tilted, folded, or broken, it happened later. So it starts off with superposition, but then erosion, earthquakes, faults, and deposition causes the rock to form a different way, which was happening later, which caused the erosion, earthquakes, or faults to be like later. So it's older. Then we have law of cross-cutting relationships. And this one is more focused on faults and dikes and things like that. So if an igneous intrusion or fault cuts through an existing rock, the intrusion or fault is younger than the rock it's cutting through. So for the example where it says dike, you see on the left-hand side it says younger, next oldest, and oldest layer. But then when the dike comes through, that means that the dike is the youngest part of that rock formation. Right. And then law of inclusion. This one is simply stating that rocks that are embedded in other rocks are older than those rocks that they are embedded in. So, sorry, I'm losing my train of thought. So, for example, in the pictures, the darker rocks that are included into the lighter looking rocks, those rocks that are inside are older. They were there first for that rock to form around that rock. So that causes that rock, the intrusion, to be older. Okay. And then lastly, we have correlation. Correlation is when the rock layer is in a different place or somewhere else, but you can correlate or match up by matching the rocks and the fossils within the rock. So you can take one rock on one location and another rock on one location and match them up and correlate and come up with the relative age because they're similar with the same fossils and everything else. Problems with relative age dating is that there could be a missing section of time in the rock that we are looking at or that we're recording. So this would be an unconformity or any conformity, which is a gap in the rock sequence that happens as a result of erosion, for one, deposition, or earthquakes and plate movement caused by the ground moving or shifting or uplifting. Okay. And there are three types that I did want to look at, which are the angular conformity. Sorry, the pictures are a little mixed up, but on the right hand side at the bottom is the angular conformity, which is younger sediments rest upon the eroded surface of tilted or folded older rocks. So in that picture, you can see some rocks are going up and then the ones on top are straight. And then we have a disconformity, which is the redder looking rock at the top on the right hand side. It's the contact between younger and older beds is marked, and you can see it visibly, or it's an irregular or uneven erosional surface. So with the picture with the red rock at the top right-hand corner, you can see that there's a clear separation between an older rock and a newer rock. And then a nonconformity is a development between sedimentary rock and older igneous rocks or metamorphic rock that has been exposed to erosion. So that would be the longer picture on the left-hand side. And that is it for my presentation. Thank you.